William Wollaston was an English scientist, physicist, chemist, and inventor in the late 18th and early 19th centuries. Despite his significant scientific contributions, Wollaston remains somewhat of an understated figure compared to other great scientists of the time like Humphrey Davy or Michael Faraday. However, his work shaped modern chemistry, physics, and the development of scientific instrumentation. Most notably, he discovered two elements, palladium and rhodium, contributed to the understanding of chemical compounds through his law of constant proportions, and improved optical instruments like the reflecting telescope. Wollaston's career was characterized by a commitment to precision, a humility that led him to avoid the spotlight, and a dedication to making incremental contributions to scientific understanding. His life offers significant lessons on the importance of intellectual curiosity, precision, perseverance, interdisciplinary thinking, and humility, values that remain crucial to achieving meaningful progress today. This video will explore the key moments in Wollaston's career, focusing on his discoveries, the scientific principles he introduced, and the life lessons that can be drawn from his character and work. In doing so, we will gain a deeper understanding of his lasting impact on modern science and how his principles can be applied across various fields in the contemporary world. Early life and education. Background and family. William Wollaston was born on August 6, 1766, in East Dereham, Norfolk, England. He was the second son of a wealthy landowner, Dr. Thomas Wollaston, and his mother, Sarah, who came from a notable family. Wollaston's upbringing provided him with ample opportunity for an education, which was not the case for many people in his era. His family's wealth and standing allowed him to attend prestigious schools and pursue a promising academic career. This social position played a significant role in shaping his early intellectual curiosity. From a young age, Wollaston exhibited an interest in a variety of subjects, especially natural philosophy, the precursor to modern science. His early education began at the Norwich Grammar School, which prepared him for entry into one of England's elite universities. Given the scientific interests he exhibited in his youth, it was clear that his future lay in a field that required both deep intellectual curiosity and a rigorous, methodical approach to knowledge. Cambridge and medical studies. Wollaston entered Gonville and Caius College at Cambridge University in 1784, where he studied for his Bachelor of Arts degree, which he completed in 1788. At Cambridge, Wollaston's academic work was not confined to a single discipline. Instead, he excelled in a range of subjects, particularly mathematics, natural philosophy, the study of the physical world, and chemistry. These subjects, along with his natural curiosity, set the foundation for his future scientific endeavors. After completing his degree, Wollaston studied medicine at St. Thomas' Hospital in London. However, his time in medical school was short-lived. He soon realized that his true passion lay not in the practice of medicine, but in pursuing deeper knowledge in chemistry and natural sciences. This transition from medical studies to scientific research exemplifies how Wollaston followed his intellectual curiosity, prioritizing the pursuit of knowledge over convention. This shift would prove instrumental in his scientific achievements and mark the beginning of his career as a prominent researcher and experimental scientist. Scientific contributions and discoveries. Discovery of palladium and rhodium. One of Wollaston's most significant contributions to science was his discovery of the chemical elements palladium, 1803, and rhodium, 1804. These discoveries were groundbreaking because, at the time, platinum was known but not well understood, and Wollaston's work with platinum ores played a central role in uncovering new elements. Platinum had been brought to Europe from South America, and although it was of interest to chemists, its full composition was still a mystery. Wollaston's investigation of platinum, particularly platinum ores from South America, led him to isolate palladium and rhodium. In 1803, he first isolated palladium, which he named after the asteroid Pallas, which had been discovered around the same time. The element's discovery marked an important milestone in the study of precious metals and catalysis. A year later, Wollaston discovered rhodium, which he named after the Greek word rhodon, meaning rose, due to the red color of its compounds. Both palladium and rhodium are part of the platinum group metals, and they have had significant industrial applications in the fields of catalysis, automotive technology, and jewelry. The impact of these discoveries cannot be overstated. Palladium, for example, has become critical in catalytic converters used in vehicles to reduce harmful emissions. Rhodium is extensively used in the automotive industry, as well as in the production of durable materials, chemical reactions, and jewelry. Wollaston's discoveries thus contributed to industrial applications and technological advancements that continue to this day, underscoring the lasting relevance of his work. The law of constant proportions. Another cornerstone of Wollaston's work is his contribution to stoichiometry, particularly the law of constant proportions. This law states that a chemical compound always contains the same elements in the same proportions by mass, no matter the source of the compound or how it is prepared. Wollaston's work in this area was crucial in the development of modern chemical theory, as it helped provide a solid foundation for understanding the fixed nature of chemical compositions. At the time, the nature of chemical reactions was still a developing field of study, and many chemists were grappling with understanding how elements combine to form compounds. Wollaston's experiments in this area were instrumental in establishing the idea that chemical compounds are formed in fixed ratios, which became a guiding principle in the field of stoichiometry. His insights paved the way for the later work of John Dalton, who developed the atomic theory of matter. This principle was foundational not only for chemistry but also for industries that rely on chemical formulations, such as pharmaceuticals, materials science, and food production. Wollaston's work helped establish chemistry as a discipline of precision, setting the stage for the future development of the field. Optical instrumentation, the Wollaston prism. In addition to his work with chemistry, Wollaston was also an innovator in optical instrumentation. His invention of the Wollaston prism was a crucial contribution to the study of polarized light. The Wollaston prism allows light to be split into two separate beams of polarized light, making it a valuable tool in studying the behavior of light and its interactions with various materials. This invention was important not only for the study of light but also for the advancement of optical microscopy and astronomy. Wollaston's contributions to optical instrumentation were part of a broader effort by early scientists to improve the precision of scientific instruments, enabling more accurate observations of both the microcosm and the macrocosm. Wollaston's improvements to the reflecting telescope, another of his important achievements, involved refining the design first proposed by Isaac Newton. By addressing imperfections in optical lenses, Wollaston's work helped create clearer and more accurate images, enabling astronomical observations to become more reliable. His improvements to telescopes contributed to the growing field of astronomy, which was expanding rapidly during this period. Wollaston's efforts helped advance the study of celestial bodies, providing astronomers with better tools for their investigations. The life lessons of William Wollaston. 1. Curiosity and perseverance in scientific discovery. Wollaston's life underscores the importance of curiosity and perseverance in the pursuit of knowledge. His work with platinum ores was driven by a deep intellectual curiosity about the unknown elements that could be isolated from the ores. Even though many scientists before him had observed platinum, they had not isolated its constituent elements. Wollaston's willingness to pursue his intellectual curiosity, despite the lack of immediate success, eventually led to the groundbreaking discoveries of palladium and rhodium. In the realm of scientific discovery, curiosity often serves as the starting point for great breakthroughs. Scientists who are driven by an insatiable curiosity about how the world works are more likely to challenge the status quo and explore uncharted territories. Perseverance in the face of initial failure is just as important. Wollaston's ability to push through challenges, such as the technical difficulties of isolating these elements, highlights the importance of persistence in achieving success. This lesson applies beyond the realm of science. In any field, the willingness to question assumptions, explore new possibilities, and stick with a challenge even when success is not immediate can lead to breakthroughs and innovations. Today's rapidly evolving world requires both curiosity and perseverance to solve complex problems. 2. Precision and observation, the key to innovation. Wollaston's contributions to science were characterized by his remarkable precision in both experiment and observation. In chemistry, his ability to isolate elements from platinum ores with great accuracy was groundbreaking. His use of meticulous methods in his optical experiments and improvements to the reflecting telescope demonstrated his commitment to precision. This dedication to careful observation also applied to his work with the reflecting telescope, where his innovations reduced distortions in optical images. The precision of his work helped lay the foundation for further advancements in optical instruments. In our own lives and work, precision and attention to detail are essential for achieving excellence. Whether conducting research, building a business, or creating art, precision often sets the highest standard of quality. Wollaston's commitment to ensuring that every aspect of his experiments and instruments was finely tuned serves as an enduring model of excellence. 3. Humility and modesty in achievement. Despite his tremendous contributions to science, Wollaston was known for his modesty and humility. Unlike many of his contemporaries, Wollaston was not driven by a desire for public recognition or fame. He did not seek to place his name prominently on the discoveries he made. For example, when he discovered palladium, he published his findings without prominently featuring his name. In an age where many scientists sought recognition, Wollaston's reluctance to pursue fame speaks to the importance of intellectual humility. His focus was on furthering human knowledge, not on personal accolades. This quality is particularly valuable in the modern age, where personal branding and self-promotion often take precedence over the value of knowledge and collaboration. Humility and modesty can be applied in our daily lives as well. Whether we are pursuing personal or professional goals, humility in the face of achievement allows us to remain focused on the greater good and on the contributions we are making to the world. By maintaining modesty, we are more likely to build meaningful and lasting relationships, collaborate effectively, and avoid the distractions of ego-driven pursuits. 4. Interdisciplinary thinking, connecting the dots across fields. Wollaston's work exemplified the power of interdisciplinary thinking. His contributions spanned chemistry, physics, and optics, demonstrating how diverse fields of study can intersect to solve complex problems. His work with optical instruments informed his understanding of chemical processes, and his study of platinum ores led him to make significant contributions to chemical theory. In today's world, many of the most significant challenges require the intersection of multiple disciplines. For example, addressing climate change, developing cutting-edge technology, or improving healthcare often requires expertise in a variety of fields. Wollaston's ability to draw upon his knowledge of several scientific areas and integrate them into his research highlights the importance of interdisciplinary thinking in solving modern problems. In professional and personal settings, interdisciplinary thinking encourages us to consider diverse perspectives, which can lead to innovative solutions and creative breakthroughs. 5. caution and integrity in scientific inquiry. Wollaston's work was marked by caution and integrity. He was known for conducting experiments with care and precision, and his conclusions were always based on thorough evidence. In an age when scientific rigor was just beginning to gain prominence, Wollaston's careful and meticulous approach set a standard for future generations of researchers. This caution and commitment to integrity were also reflected in his publication practices. He was reluctant to make sweeping claims without solid evidence, and he always ensured that his work could withstand scrutiny. His ability to balance the pursuit of discovery with an unwavering commitment to accuracy is an invaluable lesson for anyone involved in scientific research or intellectual work. In today's fast-paced world, where information spreads quickly and claims are often made without sufficient evidence, Wollaston's approach teaches us the importance of evidence-based inquiry, integrity, and critical thinking. 6. Dedicated focus, achieving success through long-term commitment. Wollaston's career illustrates the power of dedicated focus over the long term. His scientific work was built on years of experimentation, observation, and fine-tuning of techniques. Wollaston did not seek instant success but remained committed to his research over many years. His discovery of palladium, rhodium, and his work with optical instruments were the results of sustained effort and dedication. This lesson can be applied to many areas of life. Whether pursuing academic success, building a business, or developing a skill, long-term focus and dedication are often the keys to success. In a world where instant gratification is increasingly sought after, Wollaston's life reminds us that lasting achievements require patience, commitment, and steady progress. 7. The value of patience in scientific research. One of the most enduring lessons from William Wollaston's life is the importance of patience in the pursuit of scientific knowledge. Wollaston was not someone who rushed his experiments or looked for quick results. Instead, his success came from years of careful observation and methodical research. This patient approach was especially evident in his work with platinum ores, where he spent long periods experimenting before making his landmark discoveries of palladium and rhodium. Wollaston's research process was a demonstration of scientific rigor. He didn't simply accept initial results as conclusive. Instead, he re-evaluated and retested his hypotheses, making sure that the evidence supported his conclusions. This patient, methodical approach to experimentation allowed him to produce results that were reliable and reproducible. His success wasn't achieved overnight but came as the result of steady work and careful attention to detail. In the fast-paced world we live in today, instant gratification is often seen as the norm. However, Wollaston's life demonstrates that meaningful discoveries and innovations take time. Whether in research, professional projects, or personal development, patience is key to achieving lasting success. Rushing to conclusions without enough evidence or trying to achieve success too quickly often leads to mistakes or superficial outcomes. True mastery in any field requires time, careful attention, and an understanding that significant results are often the product of sustained effort. Incorporating patience into our daily routines, whether in academic pursuits, creative endeavors, or business, helps to develop a deep understanding and lasting expertise, something Wollaston exemplified through his contributions to science. 8. Focus on contributing to the collective knowledge, not personal glory. Wollaston was a scientist who consistently prioritized contributing to collective knowledge over personal glory. Despite his significant discoveries, such as the identification of palladium and rhodium, Wollaston rarely sought to take credit or fame for his work. He did not rush to claim his discoveries as his own but instead published them with modesty, allowing others in the scientific community to build upon his research. In fact, he did not place his name prominently on his discoveries, a contrast to the more fame-seeking attitudes of some of his contemporaries. This humble approach to scientific discovery underscores the importance of contributing to the greater good rather than focusing on personal accolades. Wollaston's work speaks to a broader principle: true greatness lies in leaving a legacy that enriches humanity, rather than seeking recognition or fame for oneself. In the contemporary world, where public recognition often takes center stage, Wollaston's example reminds us that the value of work lies not in personal fame but in the contribution it makes to the broader community. By focusing on the impact of our actions rather than seeking personal glory, we can make more meaningful and lasting contributions to society. Whether in business, art, or social work, making a difference often comes from working collaboratively, sharing knowledge, and allowing others to benefit from our contributions without seeking the spotlight. Wollaston's work teaches us to focus on creating value and making meaningful progress for the betterment of society rather than being driven by personal ambition or the pursuit of fame. 9. The importance of methodical and systematic thinking. Wollaston's success as a scientist was largely due to his methodical and systematic approach to research. In every experiment, he focused on creating precise, repeatable, and reliable methods to ensure that his results were accurate and valid. His careful attention to experimental procedures was crucial in allowing him to isolate and identify new elements like palladium and rhodium. His commitment to systematic thinking meant that he approached his work with a mindset of order, discipline, and organization. This emphasis on methodical thinking can be applied to virtually every field today, from science and technology to business and education. In an age where many challenges are complex and multifaceted, approaching problems with a systematic mindset, breaking them down into smaller components, identifying patterns, and understanding how various elements interact, can significantly improve the quality and impact of our work. For example, when tackling a large project, breaking it down into manageable tasks and setting up systems for monitoring progress can help avoid feeling overwhelmed and increase efficiency. Similarly, in decision-making, adopting a methodical approach to evaluating options can lead to better outcomes. In business, ensuring that operations are well organized and processes are standardized can lead to greater success and sustainability. Wollaston's commitment to methodical thinking also speaks to the importance of structure and discipline in achieving long-term goals. Whether conducting experiments, planning a project, or even organizing daily tasks, systematically approaching challenges enables us to navigate them more effectively and deliver better results. 10. Embrace simplicity and clarity in innovation. Although Wollaston made groundbreaking discoveries in the fields of chemistry and optics, he was also known for his simple yet effective approach to scientific innovation. For example, his development of the Wollaston prism, an elegant and straightforward method for splitting light into two polarized beams, was revolutionary in its simplicity. The design of the Wollaston prism used a simple yet effective principle of light refraction to accomplish a complex task. Similarly, Wollaston's contributions to improving optical instruments and telescopes were focused on enhancing clarity and reducing unnecessary complexity. His goal was to simplify designs, improve functionality, and achieve greater accuracy, principles that continue to be fundamental to engineering and design today. This approach teaches us that innovation does not always need to involve highly complex or convoluted solutions. Sometimes, the best innovations are those that simplify existing processes or create greater clarity. In today's world, where technological advancements are often marked by complexity, we can take inspiration from Wollaston's commitment to simplicity and clarity in solving problems. This lesson can be applied in fields like product design, engineering, and technology, where simplifying user experiences, streamlining processes, or reducing unnecessary components often leads to more impactful and successful products. Moreover, simplicity in communication, whether through writing, presentations, or teaching, can help clarify complex ideas and make them accessible to a wider audience. Wollaston's ability to find simple solutions to complex scientific challenges underscores the timeless importance of elegance in design and clarity in thought. Innovators today can learn from his work to prioritize simplicity in their solutions, which often leads to greater functionality and ease of use. Conclusion. William Wollaston's life provides an extensive array of lessons that extend far beyond the scientific field. His intellectual legacy not only transformed the world of chemistry, optics, and physics but also offers invaluable wisdom for today's world. From the importance of patience in scientific research, humility in achievement, and methodical thinking in problem solving, to embracing simplicity in innovation and contributing to the collective good, Wollaston's life serves as an exemplary guide for anyone aiming to make a positive and lasting impact in their chosen field. In a world that increasingly emphasizes speed, efficiency, and personal recognition, Wollaston's example stands as a reminder of the virtues of dedicated inquiry, collaboration, and long-term vision. His work demonstrates that true progress often requires patience, humility, and a commitment to improving the world, rather than simply seeking personal accolades. Whether one is involved in science, technology, business, or the arts, the lessons learned from William Wollaston's life remain relevant and powerful today. They remind us that true success in any endeavor lies in our ability to persist, remain humble, approach problems systematically, and contribute to the broader progress of society. By embracing these lessons, we can all learn to achieve meaningful success, not just for ourselves, but for the benefit of others as well.